Hello, this is Mrs. Krantz. Second video, Honors Algebra 2. I actually wanted to go through two problems kind of quickly. One from the assignment on page 618. It was number 53A. And you had to look at the equation, figure out what conic section it is, and graph it. Okay? So we're going to look at this. This is number 53, part A. And I'm going to ask myself, what do you think this is? X squared, y squared means it's not a parabola. Okay, so that's out. Now, look at the coefficients in front of the x and the y. They're different. All right, and there's no minus. So what is this? What do you think this is? Jake, Allie, John, Jalen. Oh, that's the first whole column. The first class, first period. What do you think? Did you say ellipse? If you did, you're right. All right, so this is going to be an ellipse. Now, how do I graph this? How am I going to actually put this in the calculator? I need to solve for y. How am I going to do that? Well, let's see. I want to get y all by itself. I want my y squared and my 2xy, sorry, here. All right. Then I'm going to subtract 4x squared. I need to get y all by itself. This xy term is going to do something to this ellipse. We shall see. All right. Now, I'm going to do a little technique called completing the square. All right. My a number is 1, and the b is actually 2x. So we take the b, 2x, divided by 2, and square it. Now b is normally just a number, but here b is actually 2x. So take 2x, divide by 2, that 2's cancel, and square it. So I'm going to add x squared to both sides of the equation. All right, and I get y squared plus 2xy plus x squared equals, then I do like terms over here. I get negative 3x squared plus 9. All right, now what? This is called a perfect square trinomial. All right, I'm going to write it as y plus x, the quantity squared. If you folded it out, if you took y plus x times y plus x, you get y squared plus 2xy plus x squared. Now, we rewrote it that way so that we can now solve for, remember, we're trying to solve for y. 2 more steps. Opposite of squaring, which is the square root. And final step. What do you think? Remember, when you square root is positive and negative, we're gonna, final step, subtract x. So here's what y equals. Positive, negative, square root, negative 3x squared plus 9. Then outside the square root on the end is minus x. Okay, so now we need to put this in the calculator. We should get an ellipse. But instead of an ellipse that we're used to saying, which is like a vertical or horizontal, we'll see what we got. All right, so now I have to graph this. I put this in, and I put in the square root of negative 3x squared plus 9, close the parenthesis, minus x, that's on the end. Now, I'm not able to do the negative y1 on this because that will only negative the front. All right, you got to make sure on this that the whole thing doesn't go negative. So in this case, I just have to retype it in. Okay, because that minus x on the end would not get the negative correctly. All right, so we're going to just put it in, and then I don't know what your window is. I've got your standard negative 10 and 10, and we'll get the top half and bottom half of the ellipse, and it's slanted. All right, now if I make my window a little smaller, I can see it a little better, but we get the ellipse. All right. We'll work a little bit more with these xy terms towards the very end of the chapter. Okay, but mostly the ellipse we're going to do in the beginning are either going to be up and down, vertical, or horizontal. Okay, now I wanted to do just one more quick problem, though it's not super quick. Right? I wanted to do a system of quadratic equations. Okay, and we're going to solve the system, which means find the intersection point or points of these two quadratics. All right, so what is this? First one right off the bat. X squared, y squared plus same coefficients. Hoping that you're saying this is a circle. This is radius squared. So the radius is square root 16, 4. All right, so I draw this one. 4. So we have a circle. Let's see if I can draw a better circle this time. I'm not counting on it. Do the best I can. All right. Here's our circle. Now we will put that in the calculator. How will I do it? Well, I'm going to solve for y. So y squared equals 16 minus x squared, and you square root. Right? So positive, negative. So we can put that in the calculator. Okay. Second, what is this? All right. Minus and y squared and x squared. Minus y squared and x squared. It doesn't matter what the coefficients are. If there's a minus, it is a hyperbola. This is a hyperbola. And I'll have 2 branches. Okay. And we'll spend more time on the hyperbola, of course. But I know when the y squared is first, all right, that the y-axis is where I'm going to find what are called the vertices. So this is going to be one that goes up and down as opposed to on the sides. Okay. All right, so let's see. We can put that in the calculator. It's a little bit longer to solve for y. I'm going to add 36x squared and add 1. Divide by 4. And take the square root. Positive, negative, square root. All right. So let's put that in the calculator, see what we get. All right. All right, let me grab this one here. I have a different one. I'm going to put in... Yeah, I think I got it in there. The top half, the hyperbola, the bottom half. And then we bought the circle, top, bottom half. I'll hit graph. All right. Now, what is that y-intercept? If I hit trace, I get 0.5, and then it'll be negative 0.5. Then I'll turn my other circles on, and we can get a nice picture. Ah, there we go. Now remember, you're going to get a distorted looking circle, but it is a circle. It looks like an ellipse. Okay. All right, so this was half. This was negative half. Where are they intersecting? I don't know exactly. This is a sketch. This is this hyperbola. And here. I may adjust this after we find intersections. But this is perfectly symmetrical. To me, kind of looks like a baseball a little bit with the stitching. All right. And how many solutions are there? How many intersection points? 1, 2, 3, 4. I have 4 intersection points. So we're going to solve this graphically. We're on our way. We're almost there. I have to find these 4 intersection points. I hit second trace, number 5, intersection. All right, first curve, it has me on y1, which was the top half of the hyperbola. Enter. Second curve. Now, it has me on the bottom half. I do not want to be down there. Those never intersect. So hit the down arrow, and it actually brings you back up to y3. Enter, guess, enter. First intersection point. We will have to round. We get about 1.25, comma, 3 point, well, I'll go wait. There, positive. All right. Looks to me like everything's perfectly symmetrical. All right, but let's check. Let's make sure. Is this going to be 1.25 negative 3 point? 798 or negative 3.8. Let's check. Okay. We'll find intersection. All right, let's get this bottom one. So go down. Good. That's on this. Enter. Now down. Okay. Second curve. Enter. Guess. Enter. And it is 1.25 negative 3.8. Okay. Then we'll just verify this one, double negatives. Let's do that. Intersect, down. All right, so I'm on this curve. Enter, down. And the bottom half of the circle. And let's verify. Yes, you do get the negative 1.25, negative 3.8. And finally, the second quadrant. We've got negative 1.25, positive 3.8. 4 solutions. Graphically. How about algebraically? How can we find the solutions? We know the solutions. What could I use? What method? Algebraic. What method? Everything's lined up on top of each other. We will try elimination method. Let's see. Maybe eliminate the x squareds or y squareds. What do you think? I'll go for y squareds times by negative 4. Now these are a little mixed around, so I'll go negative 4y squared, negative 4x squared equals negative 64. Okay. Then I'm going to add the 1. You get 1. Okay. Eliminate y squared. I get negative 40x squared equals negative 63. Divide negative by negative. And square root. So let's see. Let's square root. Oops. Grab this guy. Square root. 63 divided by 40. The negatives will cancel. If we're right, we will get about a 1 point. You got it. 1.25. Exactly what we got. Right. Now to get the y, plug it in. I'll just plug it in. That's simpler. Y is going to be the square root of 16 minus this 1.25 squared. So I'll square root 16 minus my answer squared. We should get about 3.8. And you're square rooting on these positive, negative, positive, negative. Put these positive negatives together, you get 4 solutions. So I didn't give you a problem like this, but I may, depending on timing and what we're doing in the future, give you a couple problems like this to solve, or maybe not. All right, but just wanted to make you aware. All right, that's it. Thanks.